Ross, and today I'm here to share my latest project with you, a standalone text editor running entirely on an FPGA. Yes, I have turned my FPGA to a standalone text editor. It works without any operating system, just pure hardware logic. So if you are interested to see how this project works, keep watching! So as you can see on the screen, we are in the starting frame of the text editor. At the top, the name of the text editor is written. And at the bottom, you can see a short guide on how to use this editor. It says that by pressing key 0, which is one of the onboard keys on the FPGA, we can open the editor and type whatever we want. By pressing key 1, you can transmit your text. I will talk about this functionality later on, but for now, let's get started and open the editor. So as you can see, this is the FPGA board. These 4 keys on the right side of the FPGA are active low buttons. The first one is key 0, the second one is key 1, and so on until key 3. If I press key 0, on the falling edge of this key, the editor will be opened. As you can see on the screen, a blinking cursor is displayed, and it shows that where we are on the screen. Now I can write anything into this text editor just by pressing the keys on my keyboard. My text editor is capable of displaying uppercase letters, lowercase letters, digits, and even symbols like period, comma, semicolon, question mark, and more. This text editor is capable of storing 4,800 characters, so we can write up to 4,800 characters into it. These 4,800 characters can be written in 80 columns and 60 rows. If the FPGA receives a valid ASCII code, but its graphics don't support displaying that character, it will show an unknown character on the screen. The text editor also supports control keys on the keyboard. If you write something wrong, you can press backspace to remove it. Or if you would like to go to the next line, you can press Enter to move to the next line. The text that you have written is saved into the block RAM of the FPGA. But let's say that you want to have your own text on your own PC as a permanent file. For this reason, I have configured key 1 as the transmission key. By pressing key 1, your text will be transmitted to your PC through the UART transmitter module. As you can see, when I press the transmission key, a transmitting message is displayed on the screen. And when the transmission is done, a done message appears. On the PC side, I have written a Python script that connects to the UART port. It receives all the ASCII codes, converts them back to the corresponding characters, and saves them into a text file. If we take a look at the text file that the Python program has created for us, we can see our text exactly the same way it appeared on the screen. Please pay attention here. We can see the hat signs properly, and the unknown character is not displayed. So the reason is that the ASCII code of the hat sign was valid, but the FPGA's font package was unable to draw it. The computer's graphics, however, are able to draw it, and since we saved the correct ASCII code into the FPGA block RAM, we get the proper text. So that was a quick demo on this project. I hope that you have enjoyed watching this video. If you're interested in creating your own text editor on your own FPGA, you will find the source code in my GitHub repository. I highly recommend you to check the README file in my GitHub repository because I have explained the logic behind of this text editor into that file. So it will give you a better understanding of how exactly this text editor works. And I have put the link of my GitHub repository in the caption of this video, so feel free to check that. And that was everything for today, and I will see you next time with another project. Bye bye!